Okay, so we are on a video for chapter 12, and the contents of this video are basically going to cover what happens to nuclear waste after basically the fuel has been used in the nuclear energy power plant. So here you can see a diagram of the entire fuel cycle, and it begins with the let me get my pen up here, screen, pointers, pen. The mining, and basically all the way up to the refining and the enrichment of the uranium. And here you have the reactor where it's used in the reactor. And then finally you need to actually store the fuel after it's used. So this is what we're going to talk about in this video. So the cycle has a lot of waste. Okay, so basically after you use the uranium, you have to do something with it. And also all of the fluid and the water that's used in that process also becomes radioactive, so that also has to be stored and disposed of as well. Okay, so you can see here you have uranium tailings. That's after you mine and you extract just the uranium from the mine. You also have to deal with the tailings, the enrichment of it, basically the stuff that isn't enriched you have to deal with. In the nuclear power plant you have low-level waste and high-level nuclear waste, which we'll talk about. Okay, and so the question is, what do you do with this stuff? You can dispose of it, or you can try to reprocess it so that you can use it again. So you can see nuclear radioactive waste, there's a lot produced each year, and it includes solids, liquids, and even gases. And you have high versus low level, as I mentioned. So low level reactive wastes include, basically objects or dust even that have been itself contaminated. So these aren't this isn't waste that was used in the actual reactor, but it's stuff that's been contaminated. Okay, so this can be dumped in what are called nuclear dumps. So it's things that were kind of touched by or in the exposed to radioactive materials themselves. And this is just to show you basically again the production cycle, and anything within this production cycle is going to be high-level radioactive waste. Okay, so the first one here is the spent fuel. So if you look here, here are the fuel rods with the uranium in it. So anytime this basically fuel rod has been used up, this entire rod and the fuel inside that's been spent is considered hot. It's radioactive. It's this high-level radioactive waste. And also all the water that is used in this entire process is also been exposed to this radioactivity, and it's also considered high-level radioactive waste. And this, if you remember in the Japan disaster with their nuclear power plants, this basically is what started leaking out, all this water, and that was a huge problem. So this, the high level includes all of these spent fuel parts, and also when this U-235, or the radioactive isotope of uranium, when that splits, you have other radioactive particles that are produced, and their radioactivity can last for hundreds of years. So this is one of the dangers of nuclear power, because you're producing all these new radioactive particles. They're not uranium anymore, but they can enter the food web through water or plant tissue, and essentially they can get into, if they get into the food web, they can actually mimic certain proteins in your body and certain vitamins. And your body will incorporate them, but they're radioactive, so they'll start to damage your DNA, and that's not good. Okay, so if you look at here, there's a diagram of the original uranium fuel. So uranium fuel, if you remember from before, only 3% of it is this uranium, this isotope uranium-235. The rest is the non-radioactive stuff, but this just 3%, 3% is enough to make it that powerful and contain that much energy. So after it's used, you basically get this concentration, okay? So the 3% uranium-235 basically changes into these products that are also highly radioactive, which is what I mentioned before. They're not uranium anymore. And then this 97% becomes usable. Some of it changes into more highly radioactive 235. Some of it changes into plutonium, which is used in nuclear weapons. And the rest still remains is uranium-238. So you can reuse that, which is good. So the question is, what do you do with all of this? Okay, so can you store it? And that's one of the big issues with nuclear energy. Not only, in addition to the kind of risks of actual power or energy production, it's the storage of the material afterwards. So this act, the Nuclear Waste Policy Act, required that there is proper storage of it. And there are many ways to do this, and they all have their drawbacks. One is for kind of temporary storage. This is basically the first step after nuclear waste, and this is for all of the high level radiation. Okay, the low level radiation doesn't need this kind of treatment. So the rest of what we're talking about is for high level radiation. And the first thing that happens is all this fuel is, as I mentioned, hot, and you put it first into a pool for the spent fuel. And again, this was for the Japan disaster. These pools for spent fuel, their water levels were decreasing, and that was a big problem. So once they're kind of cooled in this humongous pool, they're then put into these concrete casks. And they had to be guarded, but essentially they are kind of entombed in there, and they don't release any radioactivity into the environment if they're done properly. So the spent fuel pool is lined with concrete. The water shields the radioactivity, and it's only temporary. Again, it's for it to let it kind of literally and figuratively cool down temperature-wise, and also losing kind of some of its radioactivity. And this is a picture of the storage cask. Okay, so it's above ground. The nuclear fuel can't be hot when it goes in there. And again, so it goes in there after the pool. And you can see it's very heavily lined inside. And you can also do something called vitrification, which is making the liquid waste. So this is the water that's used in the nuclear energy cycle that changes to steam and that gets recondensed. You can make that glass into ceramic logs, so it's easier to store. It's a lot easier than storing liquid. So basically, vitrification is transferring that hot liquid waste to something solid like a glass or ceramic log. All right, so long-term disposal is kind of highly it's just a big issue that we're constantly having to deal with. What do we do with this long term? Sometimes, burying it underground, and there's this proposal to do under Yucca Mountain, which is in Colorado, and it's in Nevada, and it's basically thought that they would put all of this, 70,000 tons of highly radioactive material into underground. So if you can see, this is a diagram of what it looked like. Here's a building, so this is the scale here. You can see a little house, and you essentially would bury it way underground, and you have to, so 1,000 feet, and you'd have to dig kind of a mine type thing, and basically place the canisters of that spent fuel underneath this kind of network of tunnels. So that's what the proposal is. It has not yet been approved, and there have been some tectonic issues identified, so that would be a problem. If you can imagine some sort of earthquake happening there, that wouldn't be good. Okay, so other options, and you can see this diagram is kind of neat. It shows all the different alternatives for storage. So we have space. These above ground tombs are an option. And I don't really actually on here, I don't think they have it, but basically above ground tombs would be just big buildings. Putting it under the ice sheets in Antarctica, under the ocean, so the very bottom kind of depth of our ocean floor, and also potentially launching it off into space. So you can imagine there are a lot of different pros and cons, a lot of cons with all of these things. But it's just this question of, what do you do with this material that's so dangerous? It's a hard question to answer. It's a really hard question to answer. And then here's just a blow up of that figure. Okay. And then the last issue is what do you do with the nuclear power plants themselves? This nuclear power, the kind of rise of it was in the 50s and 60s, and so now as we're coming to 2010, 2011, we're starting to get this need to reevaluate all the nuclear power plants, because basically they were licensed to operate for only 40 years, and they can't be abandoned when they're shut down for obvious reasons. There's just a lot of radioactivity within them, and they're potential kind of sources for international security issues and stuff like that. So the three solutions, or the three options basically, are for storing it. Basically you don't use it, but it's just guarded, and it's the most common because it's the cheapest. Essentially you don't really have to do very much. You just close it off and then guard it. Entombment basically means encasing it in concrete, and that's the least common because you can imagine the work that would entail. And then decommissioning it basically means kind of taking it apart. So whereas entombment is just kind of covering it and entombing it, decommissioning it is you're essentially breaking down the facility. And this, as you can imagine, is the most dangerous because you're kind of getting into all of the facilities and the reactor itself. So that's also not very common. And for the connection to nuclear weapons, nuclear bombs are about 85% U-235. If you remember, nuclear fuel in the power plant is only 3% of U-235. So hopefully that's pretty evident how much more explosive and dangerous nuclear bombs are. 3% versus 85%. And the spent fuel is what is used to make the nuclear weapons. So in that spent fuel cycle, that kind of leftover stuff is used to make it, especially because you can take plutonium, which is one of the fuels in nuclear weapons often, and that it can be processed from U-238, which is the non-radioactive uranium. Okay, and then I just had to put this up here. I know this is with wind power, but the idea of NIMBY, or not in my backyard, is very kind of is a huge issue or kind of stance with regard to nuclear energy, because although some people or various people are in favor for various reasons, one being the high amount of energy, that electricity that it produces, and also the lack of CO2 emissions from this type of production. There are also many kind of problems that go along with it. So this idea of people that would be in favor of nuclear energy but not to have it in their backyard is definitely tied to this issue quite tightly, and also will be tied to many of the renewable energy issues that we talk about next chapter. Alright, so now hopefully you are ready to discuss the pros and cons of nuclear energy for our debate. Thanks so much. See you guys in class.